Good afternoon, everyone. Today's session is related to the thermal properties of the metal. In this session, we will discuss how the one state of a metal can change to another, and there are formulas as well which you have to learn. These are the learning objectives. The first part is about the thermal expansion, comparison of solid, liquid, and gas. Then how we can measure temperature by using a thermometer, and then at the last there is the thermal capacity and the melting point. So the first, the thermal properties of the matter. What is the internal energy? What is the concept of internal energy? As we know, everything is made up of particles, atoms or molecules or ions. And these ions are moving. Ions are not ions or atoms or molecules. They are not stationary. Even it is a solid, it's a liquid or a gas. These particles are always in a state of motion. In a solid, they can only vibrate about fixed position. But in liquid and gases, they can move past each other. So when these molecules are moving, they have two energies. What are the two energies they have? Number one, they will have potential energy, as they can change their position in case of gases and liquids, and they will have kinetic energy because they are moving as well. So whenever object is moving, that's called kinetic. So when we add the potential and kinetic energy of the particle, the sum of potential and kinetic energy of the particle is refers to internal energy. So if this was having 10 joules of energy, another is having 5 joules of energy, then another is having 3 joules of energy, then 2 joules of energy, 10 joules, 7 joules, 8 joules, and so on. So when we add the energy, like we sum the energies of the particle, 10 plus 5 plus 2 plus 3 plus 10 plus 8 plus 7, this result, the addition of this, all the energy of the particle, what we call that as internal energy. So sum of kinetic and potential energy of the molecule is simply termed as the internal energy. So the total kinetic and potential energy of all atoms or molecules in the material we refer as internal. So when the temperature increases, the particle will move faster. As they will move faster, it means the kinetic energy is increased. And as the kinetic energy increase, the internal energy will also increase, because the internal energy is the sum of kinetic and potential. So when we increase the temperature, the particle will move faster. As the particle will move faster, the kinetic energy increases. As the kinetic energy increases, the internal energy will also increase. And when the change in state is there, so when the temperature increase, the kinetic energy will increase. So the internal energy will increase as well. And when the state changes and the temperature does not change, like substance is melting or boiling or evaporation or condensation. So when the state changes and temperature remain constant, so what we'll observe, the kinetic energy remains the same, does not change, and the potential energy increases or decreases. So the internal energy will change as well. Now, how these statements are related, example, I will give example for both statements. Example, we have a solid and that solid is at 20 degrees centigrade. I supply heat energy, we are supplying heat energy. So this was solid, and when we supply heat energy, the solid does not melt, it can expand, the size can increase as the temperature is changing, but it does not melt, it remains in a solid state, and the temperature is, example, now 50 degrees centigrade. But still it is in a state of solid. So what happened in this example, what happened to kinetic energy? It will increase, decrease, or remain same? So what will happen to kinetic energy? The kinetic energy will increase because the kinetic energy refers to the temperature. If the temperature increases, the kinetic energy will increase. And what happened to total energy or internal energy? The internal energy is actually a sum of kinetic and potential. Because the kinetic energy is increasing, so the internal energy will also increase. So this is the first part. When temperature changes, the kinetic energy increases, so the internal energy will also increase. Is it clear, the first statement? I'll explain the second statement as well, but you should understand the first statement, that when the temperature increase for a substance, there will be increase in kinetic energy, and internal energy, which is a sum of kinetic, that will also, kinetic and potential, that will also increase. And opposite will happen. If you decrease the temperature, the kinetic energy will decrease, or the internal energy will also decrease. Any doubt till this point? Any question or doubt? Now, what about the second statement? When the state changes, when the substance is changing the state, that, as we know, whenever there is a change in state, the temperature does not change. So example, if we have a solid at its melting point, so we have a solid, example, its melting point of this solid is 800 degrees centigrade. So we have a solid at its melting point, and now what we are doing, we are supplying the heat energy further. So when we supply the heat energy to this solid, which is already at its melting point, so what happened? The energy which we supply is used to break the bonds, the attraction between the particle, so the solid will convert into a liquid state. But what about the temperature of the liquid which is formed? Because solid is melting, and whenever a substance is changing the state, the temperature does not change. So the temperature of the liquid which is formed, that is also 800 degrees centigrade. So as the temperature is not changing, when we compare the kinetic energy refers to temperature. So kinetic energy, there will be no change. But because the particles, as you can see, in a solid, the particles are tightly packed together. But when a solid is converted into liquid, the particles move away from each other, so they will have more energy, more potential energy. What happened to potential energy of the particles? That increases because the particles move away from each other. And what happened to internal energy? So internal energy is a sum of kinetic and potential, so internal will also increase. Even the kinetic, there is no change, but because the potential increases, so internal is a sum of kinetic and potential, so internal energy will also increase. Is it clear, this concept of the internal energy and kinetic energy when there is a change in state? Anyone having a doubt till this point? So as we know, whenever there is a change in state, there is no change in temperature. So if we have a solid in which the particles are tightly packed together, so substance originally in a solid state and the particles are tightly packed together. If I say the melting point of a substance is say 120 degrees centigrade. So if the melting point of substance is 120, and originally if I say in the beginning this substance was there at 20 degrees centigrade. So when I supply heat energy, when we supply heat energy to this, because the melting point is 120, so at 120 it will change into liquid. Before 120 it won't change into liquid. So first what will happen to this substance? The temperature will increase for the substance till 120. The size will also increase because the particles, as the temperature increases, they tend to move faster and they move relatively away from each other. That's why the substance expand. So we have a solid here till it reaches 120 degrees centigrade. So what happened here? Only there is a change in temperature. So when we say the change from A to B, so from A to B, what happened? As the temperature increases, the kinetic energy will increase and the internal energy will also increase. Why internal energy increases? Because internal energy is a sum of kinetic and potential. But we did not stop heating it. We continue to heat this substance. When it reaches 120, we continue to heat the substance. So when we continue to heat the substance, because 120 is the melting point, so substance will start to change the state. So when this substance start to change the state, it will turn into a liquid. What is the temperature of the liquid form? Because we know whenever there is a change in state, there is no change in temperature. So if solid was at 120 and it was melting, so the temperature of the liquid which is formed in this process, that will also be 120. The temperature of this liquid which is formed, that is also 120 degree centigrade. Because what is happening here, the solid is converting into liquid. What was happening initially, there is a change in the temperature. Here there is a change in the state. So when the state is changing, like here solid is turning into a liquid, so what we'll observe, the temperature does not change, temperature remains constant. So how we explain the change from B to C? What happened? The particles move away from each other, the temperature does not change, so speed of the particle or the kinetic energy of the particle, there is no change because the speed of the particle or temperature does not change. But what happened to potential energy? As the particle move away from each other, so they will have greater potential energy, so potential energy will increase. And internal energy is a sum of kinetic and potential. So what happened to internal energy? That internal energy will also increase. Is it clear how we relate the internal energy with kinetic and potential. And opposite will happen if the liquid is turning into a solid. If a liquid change to solid, the internal energy will decrease. But if solid is converting into liquid or liquid change into a gas, the internal energy will increase. So as we know, internal energy is a sum of kinetic and potential, and it changes according to the change in state as well as change in temperature. Then what is the meaning of heat capacity and thermal capacity? You can understand this from the name heat capacity, which or thermal capacity. It means how much energy, how the kinetic energy, there is no change, and internal energy change. Abdullah, as you can see, the formula for internal energy is kinetic plus potential. So when there is a change in state, if I say originally the kinetic is 50 and the potential is also 50. So what is the internal energy? That is 50 plus 50, that's equal to 100 joules. But when the state changes, the kinetic energy does not change. Kinetic energy remains same. So internal energy, which is a sum of kinetic and potential, the kinetic energy does not change, but the internal energy, example, if it increases, so if kinetic energy remains 50 but the internal energy is now 70, so what is the sum of kinetic and potential? So 50 plus 70, that's equal to 120. So the internal energy changes because there is a change in the potential energy. So if potential energy changes or kinetic energy change, the internal energy will also change. Is it clear now? Then what is the definition of a thermal capacity? Thermal capacity or heat capacity refers to how much energy is stored by the object when the object changes the temperature by 1 degree centigrade. For example, I have an object, it can be any object, and that object is at 20 degrees centigrade. We supply heat energy. Example, we supplied 100 joules. So when we supply 100 joule, we observe the temperature of this object increases by 1 degree. So how much energy is needed or how much energy is stored by the object so that its temperature change by 1 degree, that energy, that heat energy is called thermal capacity. So this object can store 100 joule of energy by changing a temperature by 1 degree centigrade. Another example, if we have an object which is at 20 degrees centigrade, we supplied 200 joules, and when we supply 200 joules, its temperature changes to 25. So what is the thermal capacity? The term thermal capacity or heat capacity means how much energy is stored by the object where for every 1 degree change in temperature, or energy change when the temperature changes by 1 degree. That's called thermal capacity. So this is 200 joules of energy is absorbed by the object and its temperature changes by 5 degree. But we want only for 1 degree, that if there is a 1 degree change in temperature, how much energy is needed or how much energy is stored by the object. So in this example, 200, the total energy divided by the temperature change. So 200 divided by 5, that's equal to 40 joules per degree centigrade. So the thermal capacity of this object is 40 joules for every 1 degree centigrade. Like if there is a 1 degree change in temperature, this object requires, or this object can store 40 joules of energy. Is it clear, the definition of heat capacity or thermal capacity? Any doubt? So thermal capacity is simply how much energy is needed to change temperature by 1 degree centigrade. That's called thermal capacity. So we have an object which is at example 15 degrees centigrade. We supply the heat energy of 2000 joules. So when we supply the heat energy of 2000 joule, what we observe, what we see that the temperature of this object changes from 15 degrees to 25 degrees. And the question is, what is the thermal capacity or heat capacity? So what is the meaning of thermal capacity or heat capacity? It means how much energy is needed to change the temperature by 1 degree centigrade. So this is a 2000 joules. So 2000 joules of energy is needed for how much change in temperature? For 10 degree change in temperature. So if we need the thermal capacity for every 1 degree change in, if 2000 joule is used for 10 degree, but we want only for 1 degree, so the total energy divided by the temperature change, which was 10 here, so 2000 divided by 10, it means we need 200 joules to produce 1 degree change in temperature. So 200 joule for every 1 degree change in temperature, that we call the thermal capacity or heat capacity of object. Is it clear, the concept of thermal capacity? So if we want to calculate the formula to calculate the thermal capacity or heat capacity is energy divided by temperature change. How we represent the heat capacity? Heat capacity is denoted by letter C, capital C. Energy is denoted by E, and temperature change is denoted by delta T. So C is equals to E divided by delta T. And what is the unit? Unit of energy is joule, and unit of temperature change can be Kelvin or degree centigrade. Normally Celsius or centigrade is given, so it will be joule per degree centigrade. The next one is specific heat capacity. So what is the difference between heat capacity and specific heat capacity? So specific heat capacity is how much energy is needed for 1 kilogram of a substance to change the temperature by 1 degree centigrade. That's called specific heat capacity. So example, we have an object which is 5 kilogram. We are supplying heat energy to this object. We supplied 2000 joules, and its temperature originally was 10, it changes to 12. If I say first thing, what is the heat capacity? So what is the heat capacity? Heat capacity means how much energy is needed to change the temperature by 1 degree centigrade. So this 2000 joule, so 2000 joule of energy is used to change the temperature by 2 degrees for 5 kilogram object. This is what we have. The question, the first part, if I say what is heat capacity? Heat capacity means how much energy is needed to change the temperature by 1. So 2000 joule is used to change the temperature by 2 degrees. So how much energy is needed to change the temperature by 1? So 2000 joules is the temperature energy which we supply, and how much temperature change it cause? It cause the temperature change by 2. So 2000 degrees centigrade divided by 2. So what we will, 2000 divided by 2, what we'll get? We'll get 1000 joule per degree centigrade. It means to change the temperature, to change the temperature by 1 degree, we need 1000 joules. So if we supply 2000 joule, the temperature changes by 2 degrees. This is the first part, the heat capacity. Now the second part is specific heat capacity. The specific heat capacity means how much energy is needed to change the temperature of 1 kilogram object by 1 degree centigrade. So how much energy we supply? This is the 2000 joules of energy. Is needed to change the temperature by 2 degree here, as this 2000 cause a temperature change by 2. So we divide by temperature, we'll get how much energy is needed for 1 degree change in temperature. And we need for 1 kilogram, this total energy is for how much? This total energy is for 5 kilogram. But we need only for 1. So how we can work out the energy? If 2000 joule we supply 5 for 5 kilogram, we supply 2000. So each kilogram, how much energy is absorbed by each kilogram or 1 kilogram? So how we can work out energy absorbed by each kilogram? So it will be 2000 divided by 5. So 2000 divided by 5, that's equal to 400 joules per kilogram. So each kilogram required 400 joules. But for every 1 degree change in temperature, so what is the total temperature change? The total temperature change is 2 degrees. So it will be 400 divided by 2 degrees. So we'll get 200 joule per kilogram degree centigrade. So what it shows? It shows if we want to change the temperature of 1 kilogram object, how much to buy 1 degree centigrade, how much energy is needed? We need 200 joules of energy. So the difference, when we talk, the difference only between the heat capacity and specific heat is the mass. In heat capacity, we do not use the mass of an object, but in specific heat capacity, we use the mass, and we are finding how much energy is needed for 1 kilogram object. How we can calculate this? The formula to calculate the heat capacity. So heat capacity is equals to energy divided by the mass of an object multiplied by temperature change. So this is the formula we use for specific heat capacity. So specific heat capacity is how much energy is needed for 1 kilogram object, but heat capacity is not about the mass of an object. It is simply energy needed to change the temperature. I'll give some examples to work out the difference between heat capacity and specific heat capacity. So if you want to calculate the heat capacity, that is energy divided by temperature change. And specific heat capacity is equals to energy divided by mass into temperature change. So these are the two formulas how we use in exam. If I say I have an object, so if I say I have an object which is having a mass of 50 kilogram, we supply heat energy of 10,000 joules, and we observe its temperature. Originally the starting temperature, we can say T1, was 25, and the final temperature, it changes into 28 degrees centigrade. So if the question is calculate the heat capacity, so how to calculate the heat capacity of this? This is the energy which we supply. This one is a mass of an object, initial and final temperature. So temperature change are also denoted by delta T. So 28 minus 5, that's equal to 3 degrees centigrade. So if you need heat capacity, how to get the heat capacity? The total energy, the 10,000 joules divided by temperature change. What is the temperature change? 3 degrees. So 10,000 divided by 3, it is 3,333.3 joule per degree centigrade. So means for every 1 degree centigrade, we need 3,333 joules. But we don't have to consider the mass because mass is not needed for heat capacity. But how to get the specific heat capacity? Specific heat capacity is how much energy is needed for 1 kilogram to change temperature by 1 degree centigrade. So the total energy which we supplied, that is equals to 10,000. Mass of an object is 50 and the temperature change is 3. So 10,000 joules of energy supplied. So this was 10,000 divided by 15 to 3, 1500. 10,000 divided by 1500, what's the answer? 10,000 divided by 1500, so it will be 6.66 joule per kilogram degree centigrade. So what does it mean, the two values? What is the meaning of the first value? The heat capacity means we need 3,333 joules of energy to change temperature by 1 degree centigrade. And what is 6.66? What this stands for? It means we need 6.66 joules of energy to change temperature by 1 degree centigrade for 1 kilogram object. So that is the meaning of the heat capacity, that you need 6.66 joules to change temperature by 1 degree for 1 kilogram. This whole object was 50, but when we talk about 1 kilogram, how much energy is needed, we call that as specific heat. But when we talk about the whole object, we call that as a heat capacity. Is it clear the difference between the heat capacity and the specific heat capacity? Anyone having a doubt or a question? So these two formulas are important. You have to learn these formulas for heat capacity and specific heat capacity. This is the same formula. We can just rearrange the formula. Like if we, as we discussed, that specific heat capacity is equals to energy divided by mass into change in temperature. So if we need energy, it will be mass into specific heat multiplied by change in temperature. We'll solve this question, less than a minute left, so I will share another link and continue this topic.